Yep, once again, Brian Roper is connecting up things in ways in which they were never intended to be. So what do we got here? We see a toaster. We got a three-way switch. There's an outlet right there. And we get a motor. So what are we trying to do here? Well, we're trying to use this toaster as a dynamic brake to stop the motor. Will it work? We have no idea. I mean, so let's see what's going on here. Yep, there's our power coming in. Goes to like one of the traveler wires. Your toaster goes to the other traveler wire. Common on the toaster goes to the live input of the motor. And you got your neutral, or should I say grounded, because it's not a three-phase system. We got our neutral right here. Grounded conductor, because that's not a three-phase system. You only have neutral when there's a three-phase system. This is a single-phase system. We have grounded conductor coming here, going to the ground of the motor, going here, and going to the toaster. We got our toaster in parallel with the motor, and that's about all you need to know there. It's all there. I mean, I hook this up like this. Yeah, it makes electrical sense. So, there's only one thing to do. Fire it up and see what it does. Actually, we have no live wires here, because our live wire goes in the transformer up here. And we basically have it, we have a 1-to-1 ratio here. So we basically have 120 coming in there, 120 coming out here. Well, actually, there's 240 coming out because of the way we have this rigged up. But we only want on L2. Because we're here, we have L1 and L2. Basically, this would be 240 and this would be 240. But across just two wires, you got 120. Basic single-phase system for house wiring. So there's that. So there's only one thing to do, plug this in and see what it does. And I will tell you, you do not use an $80, what is that, 12-3 extension cord to test stuff like this. Yep, always use this one. You always get like a cheap one, 5-footer, in case you break the end of that. Like plugging it in, it shorts out. And damages that. So let's go on with that. I know what you want to see. You want to see that. So we're going to go do that. Go ahead and try it. I mean, it's not like it's 600 volts, 1800 amps. It ain't gonna blow up like that. And that's 120. 15 amps in there. Yeah, plug it in. Go waste some time. Yeah, camera's rolling. You checked it 4 times. It is rolling. Plug it in. Alright, you're good. Okay, motor's on. Okay. Don't get in the way of the camera, Brian. Come over here. Get the motor running. So what we're gonna do, we're gonna come down here. There's no live power anywhere. We're going to come down here and we're going to engage the dynamic brake with the three-way switch. Okay, shut it off. And let's spin for a minute. Go for it. Okay. And, oh yeah. Slow it down a little bit. Not very much though. Okay, do it again. This time, hold your button on there. Hold your hand on it now. Wind up again. Okay, wind it up again. And go ahead. Make this and just switch up twist on instantly. It's strong too. Doesn't do it very much though. Alright. First, okay, do it again. Hit this. Right. I should have toasters up all the way. What it's not is like flip the switch. Yeah, flip the switch. Oh yeah. Yeah, it's doing it. Yeah, ground too hot. Yeah. It spins a lot longer that way. And it's got an effect on it, but not like much. Try it again. Push the toast on. Push the toast on all the way. And got turn on and stop it. Not by much though. A little slight effect, not much. Yeah. I'm surprised it did that. Well, it was worth a shot. Yeah. Good. Don't do stuff like this. Good. Check out the resistance if it gets hot. This is a bad idea. I don't ever try something like this. You got it. Don't know. Yeah, no heat at all whatsoever. Yeah. And there's a slight effect. It's not by much though. I thought it would be a lot more than that. Gotta keep jogging that motor and see what it does. I mean, yeah, get this full power and shut off. Yeah, goes a little longer that way. I mean, you can see it jump a little bit when the toaster's on it. You can see it move a little bit. Yeah, that's a little effect. Not much though. Okay, bring it up. Yeah, you just flip it off. Yeah. Oh yeah, it's definitely got an effect on it. I do see it jump when the toaster's on. Again, shut off. Yep, doesn't move. Yeah, shaft doesn't move. Turn on. Engage the toaster, and good. Yep, bounces. Yeah, it's definitely got an effect on it. Yeah, there's a little residual magnetism in there to do that. Not much though. Yeah, you can see it all night. It's like hot. It's not even hot. Your motor's not even hot, Brian. This. It bounces. And you can see a slight bounce on there. And it's got a little effect on it, not much though. Get a bigger toaster. Is that a double slice up there? Although I don't think the button on the double slice works. So I think that's what we could do. Yeah, we can't do it. We can't hook that up. Do you have any bigger loads we can put on here? I mean, don't forget to unplug that. Yeah, toaster's up all the way. Yeah, you're up to max heat on the toaster. And boy, I tell you, I want to see a voltage and current reading on that. I really would like to see a voltage and current reading on that. Well, let's go up and get the meter and test it out. See what it does. Your current going the right way? Oh yeah, your current's going the right way. Okay, go for it. So let's hook this up and see what it does. So we're getting what? That was that. It says 0.45 amps. So let's switch this motor on and see what it does. Guess it's on. Yeah. That's not working right. That is not working right. That didn't go up. Yeah, that's definitely not working right. Huh? Yeah, I don't see anything there. Gotta take it off. Yeah, take it off there. Yeah, I don't think that's working right. Still got the ghost reading on there. And it's still giving me that ghost reading. Yeah, flip on again, see what it does. Yeah, nothing. No response at all whatsoever. Yeah, we're in AC amps. Actually, no, we're in DC amps. Try AC amps. Shut off. Shut off and do it again. There should be something though. Yeah, in DC amps, there should be something. Yeah, turn on. Ah, there you go. Now you did it right. Fuck it. Start over. You see that? Okay. We got our meter connected up here. We got on AC amps on the clamp. So we're going to turn it on and see what it does. 14 amps. 14 amps in rush. 3.4. It's saying 3.14. Yeah, it's fine. Okay, shut off. Now we come here. Okay, there you go. Yeah, your AC amps are working right. So we come over here. Come here to the toaster. Which one do you want? Dude, there's nothing live there. You ain't getting shocked. You have a transformer there. It doesn't have a grounded coil. I mean, everything was running fine though. What do you need? I think I need, which one goes there? This one is going. This one is going into the motor. Yeah. And it's going to be flowing like this way. Yeah. Good. Yeah, we want it to go. We want the arrow to go that way. You want on this one, arrow goes that way. You got it. Now turn on. Okay, turn on. Shouldn't be anything there. Yeah, good. Now come over here. This will tell me if it's really working. So we're going to come over here, we're going to turn the toaster on all the way. We're going to come here and engage the dynamic brake and see what it does. Yeah, we got about an amp there. Yeah, it went up to 1.212 amps. And so we do have an effect on there. And you can see it right there. Okay. Engage the toaster and flick it off. Didn't do it that time though. Try it again. I think I have to button down all the way. Button all the way. Come here. And flip the switch. Dude, there's nothing live there. It's not going to shock you. So. Oh, it's a 0.8 though. 0.08. Yeah. I mean, it did work. Right. I mean, you saw it. It did work. I'll do it again. Let it run for a second. Engage the toaster. That's up all the way. Engage the dynamic brake and shut it off. Come on, do it. Yeah. Yeah, tell you what, that's not a lot of current. I wonder if I had a dead battery or something in there. Put on DC amps and see what it does. Okay, let's put it on DC amps and see what it does. It might do something. Turn on. Okay, we're in DC amps now. Boy, tell you what. I want to hook that toaster up to voltage and see what it's doing. Okay. Oh, wasn't that? No. Off. Nothing. DC amps didn't do anything. So what we want to do, where do we want to go? We want to measure voltage across here. That's what we want to do. We're going to measure voltage across there and see what it does. I don't care if I ruin this meter, it doesn't work very well anymore. Here's the leads. Yeah, start recording. Here's the leads. Put them in there. Put on voltage. Give me AC volts. Push your leads in there. Take your alligator clips off. Yeah. Gotta take your alligator clips off. And hopefully this doesn't blow the meter or something. That's a resistive load. There shouldn't be any induction in there. Go ahead, put it in there. There's nothing live there. Put it in. Yeah, we're in AC amps. It's reading 67 volts. I don't think I should be doing that. And maybe there is live power here. Okay, you're in. Oh, you're in. Okay. Put it up there so that they can see it. You see that in the camera? Don't let that meter fall to break. You see that? Okay, we're going to go ahead. Put the resistor. Don't even monster. Okay. Good. Crank it up. Don't drop the meter. 18 volts there. You see that? There's 18 volts there. Alright, we're going to engage the toaster. Okay, engage the toaster. 0 and see what it does. I think it's going to do it. See what it does. Wait, you're off. I can't read that. That did something. Okay, turn it off. Turn the motor on. Turn the motor on. Do a quick slide. Don't fall and break my meter. 22 volts. Alright. Engage the dynamic brake and see what it does. Drops to 0 as it should. And we go here and just flip the switch. Well, I think it says 21 volts. Turn it in. One again. Engage the dynamic brake. We'll have to look at these numbers later. Down 0, 0 out, and stop it. And got. I can't read that. I think it's at 29. I'll look at the tape later. Yeah, can you see that? If you can see that. One more time. We're on. Okay. We get about 24 volts across that. So we engage the toaster. Down to 0. Okay, flip the switch, and we do this. Didn't do it that time. I wonder why I didn't do that at the time. Go ahead. Do it again. On. Okay, running about 23 volts across the toaster. Push the toast button down. 0 it out and flip the switch. Okay, 1, 2, 3, and go. Yeah. Tell you what, now we're getting readings that don't make sense. Oh, you can. You're gonna make contact. Your wire's out. Your wire came out. I think you're out. You're good. Okay. So we're going to put the motor on. Well, I'll tell you what, those are not good. Motor on, and dynamic brake on, and Jesus, I didn't do that before. Okay, motor on, and dynamic brake on. Yeah, that's off. Okay, good. Dynamic brake engaged, and now it's, yeah, good. Alright, we got our motor running. Turn the toaster on. Okay, turn the toaster on. Go ahead and engage the dynamic brake and see what it does. Okay. Yeah. Change it a little bit. Yeah, we're having a failure of some kind here. I ain't much fun. Dude, you pull the wire out. Be careful. There's nothing live there, you idiot. There's nothing live there. Although it does say 39. Get in. Get the fucking in. Yeah. Alright, you're engaged. Alright, you're in. Turn the motor on. Yep. 22 volts. Okay, flip the toaster on. It should go down to 0. 0 and engage the dynamic brake and yeah. Oh, yeah. That it went to overflow. Yeah. There's a lot of power going through there. That voltage went up way too high. Do it again. Alright. Motor on. 20 volts. Turn the toaster on. 0 out. And turn the dynamic brake. And it just won't show the voltage. Which means it's in the range of thousands of volts. From the power surge. That is an inductive load going to a pure resistive circuit. Yeah, put it in, hit this. Turn on. Alright, turn on. Toaster on. Zeroed out. Dynamic brake. And yeah, your meter's not working right. You're gonna destroy this thing. And camera's still rolling. Okay. Motor on. Motor's on. Toaster's up all the way. Push the toast button. Engage dynamic brake. Yep. It's doing it a little. It's a little friction on there. Okay. You're not making good attention there. Don't let that meter fall. Do not let that fucking meter fall. Come on, stay up there. What the fuck are you sliding for? Why are you sliding? Stay up there. Get up there and stay. Okay. Alright. Motor on. Motor's on. About 30 volts there. Push the toast button. Should zero out. And dynamic brake is on. Yeah. A little bit, but not much. And we got a little bit of drag on there, but not much. Not as much as I want there to be. Okay. Alright. Alright, motor on. About 30 volts. Toaster on. Drop it to 0. Engage dynamic brake. Yeah. Slows it down really quickly. Alright, motor on. Motor on. About the same as it was. And just shut it off to see what it does. About the same. There's a little effect on there, but it's not much. That's not as much of an effect as I want there to be. Come on. Okay. Toaster on, 0 out, and dynamic brake. About 38 volts there, yeah. You need to slow it down a little more. Alright, motor on, full power, you're up and off. Yeah, it definitely turns a few seconds longer without the dynamic brake. So, this is actually working right. It's doing it, but it's not by much. Is that toaster out in there? Dude, there ain't no live power here. Not the way I have this hooked up to my transformer. Alright, power on. Do it one more time. 30 volts. Toaster on. 0 out. Engage dynamic brake. Yeah. It doesn't do it every time, but it actually does do it. I'll show you with stopwatches so you can fast get up to full power and off. Yeah, it does turn quite a little bit longer. Yeah, there is a dynamic braking effect on there, but it's not by much. Let's see that one more time. One more time. And dynamic brake is on, and toaster's on. Engage dynamic brake. Okay. Yep. Motor on, full power, and off. It definitely makes a lot more noise longer that way. Okay, see if the motor jumps. You get the motor there. See if the it's like turns a little bit. The motor's not hot. You're fine. Guys, see if that like shaft jumps. Now watch it right here. Okay, power on, toaster on, and off. Yeah, definitely move the shaft a little bit. It bounced. Okay. Power's off. Motor on. Full power and stop. Yeah, the shaft does not bounce like it does when you engage in a dynamic brake. And it is working, but not by much. I think we're going to need a heck of a lot more toasters. How many ohms is that toaster? So what's that like? I think it's 720 watts. What's this toaster? What the hell is this? Come on, where's a freaking watch on that? Come on, where's a watch on the thing? Can't read it from that angle. And we got 750 watts. So if we want to calculate the resistance, we know the voltage and we know the wattage. We want to calculate the resistance. So what is that like? Voltage squared divided by watts. Yeah, I think that's what that is. Pretty sure that's what it is. So we do parentheses 1, 2, 0, caret key 2, close parentheses, divided by parentheses 750 watts. Okay, close parentheses and get syntax error and equals 19.2 ohms and 19.2 ohms. So we need a resistance a lot lower than that, because that'll draw more power. Yeah, the lower the resistance, the harder the motor's going to have to push to get past it. The more it's going to grind the motor to a halt. The lower the resistance, the more that motor's going to grind to a halt, because that's how it works. Because if the resistance was higher, that's not going to take up as much current. The lower the resistance, the more current it's going to take up. And that's what you want. You want to pull current out of the motor, because that's what's going to make the magnetic field stop it. I hope you're learning something here. And this is how Brian Ripper does things right here. Does this all the time. This is his way of thinking. Yeah, short circuit is like 0 ohms. Where, yeah, fuck